to my math YouTube channel. So far we have covered many different types of techniques and methods of evaluating the integrals of definite and indefinite integrals. We use the substitution, the partial fraction methods, integration by parts method, and the simple techniques as well. So guys, in this video and in the coming videos, I want to do some challenge problems. Guys, again, we'll still be using those same techniques, but there is some more concepts and things that are involved in evaluating these integrals. Guys, I personally find them fun and interesting, and actually I found these examples from many different sources. It was looking at many different textbooks and some internet resources, and finally I chose 5 of these that I would like to share with my students here. So guys, starting with this one. So if you look at this guy, if you have been following my videos, or if you have been doing these on your own as well, I already covered how to do the integral of an ln of x, and that can be done using the method of integration by parts. It is not too complicated, but one has to like rewrite that ln of x as the product of ln of x times 1, and then treat it as an integration by parts method. Okay, but guys, here it is not just the ln of x function by itself, and that's what makes it a little challenging. There's an absolute value with it, okay, and then there's one more thing. It is restricted. The values for x are restricted between 0 and 1, so it is not valid for all the values for x, which also makes it easy for us to work with, because now we know what we have to work with. X is between 0 and 1. So guys, in order to actually evaluate this, again, there's no direct ways of evaluating something which has an absolute value with it. Okay, if it did not have an absolute value, it was easy. We have already done it, or we could do it right here as well. But let us see how to handle this absolute value. In order to do that, guys, the first thing that I would suggest everybody to do is let us look at the nature of this log function when x is restricted between 0 and 1. So how are we going to do it? On the side, what I'm going to do is, I know ln of x is, and that is what is inside the absolute values, and we know ln of x is same as log of x base 10, right? That is the base here, base 10. Now guys, if you have access to a calculator, or you're allowed to use a calculator, then go ahead, use a calculator. But here, let's say I cannot use a calculator right now. So what I'm going to do is, I'm going to choose particular values for x, but keep in mind, we are restricted between 0 and 1. We cannot take anything less than 0 or anything more than 1. And even we cannot take 0 and 1, because it is strictly less than on both sides, okay? So what I'm going to do is, you are free to choose any values between 0 and 1. I'm going to choose ones that I can evaluate the logs for. So how about if I choose x equals to 1 over 10? Is that between 0 and 1? Yes. And if I evaluate this log of 1 over 10 base 10, guys, you can use a calculator if you don't know how to directly do it. But if you do, then you know this is going to be equal to just a -1. Okay, so we're trying to see if there's a pattern, if there's something special or unique going on with the log function when we restrict x between 0 and 1. So we got a -1, okay. Let us try another value. Let us see, x is 1 over 100, still between 0 and 1. Guys, again, feel free to use any other numbers between 0 and 1. Guys, what is log of 1 over 100 base 10? So 1 over 100 base 10 is going to be -2. So guys, if you keep on taking some other values, and I mean, you should check with other values, again, if you have a calculator or you're allowed to use one, then what we'll see is every time we find or evaluate the log of this number less than between 0 and 1, we'll get a negative number as the answer, okay? So that is something very special happening in this particular case. Guys, the ln of x is always going to give me a negative number here, right? But what do we know about the absolute values? Guys, absolute value of any quantity is always positive. Why? Because absolute value is the distance. The idea of an absolute value is one of the ideas is the distance from the origin, and distance is always going to be a positive quantity, right? So absolute value of any quantity is always positive. What does that mean? That means the absolute value of this ln of x is always going to be a positive quantity, is always going to be positive. So this cannot be equal to just simply ln of x, because that is what the students, most of the students make mistakes here. They think that this is just going to be ln of x, because they think it is always a positive, and ln of x is, logs are always kind of positives most of the times, not always. But guys, that is the mistake here. Why? Because when we play around with these numbers that are between 0 and 1, and we try to explore how does the log function look like between x being between 0 and 1, what we see and observe here, that every time we are going to get a negative number. So guys, this is not going to be true because absolute value of this is always a positive number, but this quantity is always going to be negative, right? Since this quantity is always negative, we have to do something to this quantity to make it positive. So what do we do with negative? If I have a negative 3, one of the ways to change it to a positive quantity would be, well, there's more than one ways, but one of the ways would be if I multiply it by negative 1. So what we can simply do is we can multiply this guy by negative 1, or for that matter, we could multiply by any other number, but there's no coefficient here in front of the ln x. So we want to keep this like exactly equal to each other. So in this case, it would make sense to multiply just by a negative 1 because that's not going to change the ln of x, right? So when I do that and simplify, it will just become negative ln of x. So guys, that is a very important and a key step here to realize the fact that the absolute value of this quantity, or for that matter, absolute value of any quantity, is always positive. But then ln of x by itself, when we explore this, is going to be negative. How do we change it to positive? You multiply by negative 1. So it's like this. Guys, absolute value of 2, we know is going to be positive 2. But if I'm getting something like a negative 2 all the time, how do I change it to a positive 2? I multiply by negative 1, or I divide by negative 1, which is the same thing. Okay, so that is the whole idea here. Guys, once we get that is a very critical point, then we can now start evaluating the integral. But guys, this analysis piece on the right hand side and then thinking and making sure that this equals to that is the most critical piece of this particular example, and that is what makes it a little challenging. So now let us go back and let us see that this guy can be replaced by just negative ln of x and dx. So we can evaluate this. I have already evaluated the integral of ln of x in one of the videos. You can go back and look at that, or in this section of integration by parts, or if you already know, that's fine. In here, guys, I'm actually redoing it, okay? So what I'll do is I'll take out that negative outside, and then I have ln of x dx. Or you know what, I'm already going to skip some steps. I'm just going to break it down as ln of x times 1 dx. So guys, this product of 2, and I use the integration by parts. Of course, the log function takes the precedence over most of the other functions. So this is going to be my f, this is going to be my g. Let me write the integration by parts formula the way I like to use it. If you have your own method, because most of the textbooks don't write the formula the way I like to write it. Guys, you can keep using your own one, or check mine, go back and look at my integration by parts method. If you like that, then use that one, okay? So mine is like this. It's like f times integral of g dx, and then minus I have integral of f prime times integral of g dx, and of course there's another dx all the way at the end. Guys, this is what I prefer. Again, this is how I learned when I actually learned this stuff for the first time. So I keep using this method. If you like this one, it's more easier for me to use this formula. Usually I don't find this in all the textbooks. Guys, if you have seen it, that's fine. If not, use the one that you know, and if you're already confident using that, that's fine. The goal is to actually evaluate the integral, right? So let us go ahead and see if we can apply this and evaluate the final integral. So I think I have enough space here. So f is just ln of x times integral of g dx. Integral of 1, guys, I don't have to just write the whole integral of 1 thing. I know integral of 1. We know integral of 1 is just x. So this is x minus. Then let us evaluate this other piece. It's integral of f prime. Guys, the integral of ln of x is just 1 over x, right? We know that. Then there's times integral of g dx. Integral of 1 is again just x. And then there is this, I can put it in parentheses, there's a dx here. Guys, usually we like to write the algebraic function in front of the log function, because then they are multiplied, so that does not change anything here. And this right here, the second piece, the x's will cross out, so it is just minus integral of 1 dx. So it just simplifies, it's x ln of x. Integral of 1 dx. Guys, integral of 1 dx is what? Integral of 1 dx is simply x, right? And then there's a plus c. Okay, so that is the integral of ln of x times 1, right? So let us bring it all together. Guys, there's a negative outside. let's not forget about that negative. So I think I can get rid of this. So from here, let me take it up right here. So guys, there's a negative outside, and then we evaluated the integral of this. And what is the integral of this? It is, again, inside the parentheses. Because why inside the parentheses? Because this is not just one term, there's three terms, and then we have to finally distribute that negative. So it's going to be x ln of x minus x plus c. Okay. You know what? In order to avoid some confusion, let's not bring in the c right now. Let us do that all the way at the end. Okay. So this is going to be negative x ln of x plus x, and then I can put a plus c at the end. Guys, this is the final answer. So guys, when I was actually doing this example on my own, so what happened, I looked at this particular example and I thought about the steps that I should take in order to evaluate this. I started playing around with these numbers and see how does the log function behave. From that, I was able to realize that this is going to be equal to the negative times of the ln of x. From there, I started doing all this work, and this is what I got. But guys, then I looked back and I realized that this was a multiple choice. This was like there was a multiple options. Like there was 4 options that I had to choose from, right? It was a multiple choice test. It was a part of a multiple choice test. So I did not see this as one of the answers, and I was a little like shocked. Why is this? Maybe I made a mistake or something. So I went back and I looked over my work, but I still got the same things. But then what I realized was, guys, that this guy, so in the options, all these options had absolute values in there. So what I was missing was that this piece right here, guys, this piece, if I go back and look at my first critical step, I realized that, hey, ln of x and this, they are related. So I can just rewrite this as absolute value. How can I get this as an absolute value? I just had to solve for this, means I just had to get rid of this negative. So I multiplied negative to both sides. So what I got was a negative ln of x. So this was same as minus x and then times negative, ln of x. And where did I get this from, guys? This I got from this key step that I started with, right? And then there was this plus x, I didn't have to worry about that. And then when I simplified this, what I got a negative times negative. Guys, keep in mind, this negative is not inside the absolute value, it's outside, right? Because here, when I solve for ln of x, all I have to do is I just have to bring this negative outside to this side, okay? And then when I multiply these two negatives, they become positive, so final answer is x ln of x. Of course, ln of x has to be in the absolute values, right? And then there is a plus x plus c, and this was the option. And then I also checked that this actually is the right answer, right, guys? But if you're not doing, if you see something like this on a multiple choice, then of course one has to know how to get from here to here. Otherwise, if you just have to get the final answer, guys, this is totally fine. This is the final answer. Okay, guys, this is the first challenge problem. It's fun and exciting for me to actually do these problems and then share it with my students. And I hope you find them fun and exciting, and I hope they challenge you as well. So guys, keep trying these, keep practicing this. I'm going to show you more of these, and then we are going to try and see how we can actually use all the concepts, all the things, all the theories, all the techniques that we have learned to actually do these challenge problems. Okay, guys, till then, take care. I will see